Hello, ladies and gentlemen. It is now time to move our unit forward from learning about adding and subtracting integers to adding and subtracting rational numbers. To reflect back, we learned that rational numbers are any set of numbers that can be made into a ratio. So we're going to start with a problem like negative 3/4 plus negative 3/8. So the first step in solving a problem like this is to check to see if there are common denominators. You can't just add the denominators if they're not the same. In this case, they're not the same. So the first thing we must do is create common denominators. So what number do we know that both 4 and 8 can go into? Well, we know if we multiplied 4 times 8, we would get 32. But we don't have to go that big. That can make some really large numbers, and larger numbers are more cumbersome to deal with. So we'll look at what we know as our least common multiple. And our least common multiple in this case is 8. 4 is a factor of 8, and 8 is a factor of 8. So we will rewrite this in terms of 8 as the denominator. Therefore, we're going to keep the signs and all the operations the same. In order to change this denominator to 8, we have to multiply the denominator by 2. So 4 times 2 is 8. Well, what we do to the bottom, we must do to the top to get equivalency, to make it equal. So 3 times 2 is 6. 6/8 is the same as 3/4. Now we can proceed through with the rest of the problem because we now have common denominators. Go ahead and write this work down on your paper where it asks you to show your work. You can pause the video if necessary. I will move on. Now that we have common denominators, we need to next look at the operation. Are we adding or are we subtracting? If we're adding, we can simply jump down to step 4, where we're just adding the problem as usual. If we're subtracting, we need to work to find the additive inverse in order to make it an addition problem. Here, our operation is addition, so we can just jump down to step 4. So we're going to use our integer rules to add. Same signs, add and keep. So we have both a negative number adding to a negative number, therefore they have the same signs. So we're going to add these two numbers together and then keep the negative sign. 6 plus 3 is 9. And you can't add 8 plus 8. You're just keeping that same denominator. That is the quality of the fraction. It is an eighth. We have 9/8. Okay, 9 is the quantity of, and the eighth is what we have the quantity of. We have 9 1/8 portions. So we're not going to add 8 and 8 and get 16 because we don't have 16ths. We have 9 1/8. This is our final answer? No. Same signs add, but also keep the sign. We have negative 9/8. Now are we done? Still have one more step to do. Always, always, always want to simplify. But you can pause the video and show this work on your paper. And then you can unpause it when you're ready to move on. we're going to do that one last step. We need to simplify. If the numerator is larger than the denominator, then you're going to want to change this number into a mixed number. How many times can 8 go into 9? The answer is 1 time, with 1/8 left over. There's one group of 8/8 that I can take out and have 1/8 left over. This is your final answer. Go ahead and pause the video and practice the rest of the 2 problems on the front page. Okay, so now that you've had a chance to practice with the 2 problems that were there, let's review the solutions. They're both subtraction problems. The first one is 2/3 minus 3/4. Step 1, look for common denominators. We don't have common denominators. So step 2, create common denominators. Least common multiple here would be 12. So I'm going to rewrite this expression in terms of 12. Therefore, 3 times 4 equals 12. So therefore, 2 times 4 equals 8. 4 times 3 equals 12. So 3 times 3 equals 9. So 8/12 minus 9/12. Same signs, add and keep. Well, we don't have the same signs. We have a positive 8/12. Well, we can't use this, actually. We can't do same signs, add and keep. Why? Because that's an addition rule. Okay? We don't have different... We can't use addition rules for subtraction, is what I'm trying to say. So, we have to use subtraction rules. And subtraction rules says to look for the additive inverse. So we have 8/12 minus 9/12. To find the additive inverse, you keep the 8/12, change to an addition problem, use the opposite. So here we have negative 9/12. Okay? We're adding the inverse. So the opposite is from positive 9/12 is negative 9/12. Now we can use our addition rule. Same signs, add and keep. Different signs, subtract. So we have a positive 8/12 and a negative 9/12. So we're going to subtract 9 minus 8. Okay? 9 minus 8 is 1. Stick with me here. I know it's a negative 9, but stick with me. So 9/12 minus 8/12 is 1/12. Okay, so different signs subtract. But the rest of that poem says keep the sign of the larger number. Well, the larger number here is 9/12. And the sign of that number is negative. Then you'll be exact. Same signs, add and keep. They're different signs though, so different signs subtract. Keep the sign of the larger number, then you'll be exact. So here we had to subtract. Let's take a look at the other problem that you had to practice. This should be your answer for the first practice problem. And now the other practice problem was negative 5/7. Negative 5/7 minus 1/5. Again, we can't use our addition rules yet because we have a subtraction problem. So we're going to make this, we want to get common denominators. We don't have common denominators first. So to get common denominators, I'm going to use probably 35. It looks like the lowest common multiple. Keep my operation, keep my integer or my positive and negative signs there. Okay, so 7 times 5 is 35. Therefore, 5 times 5 is 25. 5 times 7 is 35, therefore 1 times 7 is 7. Now we're ready to look at subtracting. How do we find our additive inverse? So I keep my 25 35ths, change to the additive, find the inverse. So I'm going to have negative 7 35ths. Now that I have an addition problem, I can use my addition rules. Same signs, add and keep. Different signs, subtract. So negative 25 plus negative 7. Same signs. They both are negative numbers. So we're going to add them, which will get 32, and keep the sign. And don't forget your denominator. Is there a need to simplify this problem? No, there's not. There is no number that is both divisible into 32 and into 35. That's your answer. Okay, congratulations. You're done.